Hi, future doctors. Welcome to the next session. Today, we will discuss about electric charges and fields. Next topic. Previously, we discussed about properties of the charges. Charge is additive, charge is conserved, charge is quantized, and we have done some problems on quantization of charge. Now, in this Coulomb's law, between two charges, how the force is going to exist. So, previously in theory, we discussed between comb and pieces of paper, some attractive force is going to be there. Between our hand hair and TV screen, some attractive force is going to be present. This attractive force, we said electrostatic force. Which force? Electrostatic force. How this electric force between two charged bodies? Here charged bodies, comb and pieces of paper. The TV screen and hand. In exam, they will ask silk rod and silk cloth and glass rod they will ask. Like that they are going to ask. So however, they are going to give force between two charges. If two charges separated by some distance R. If this comb at home, your home, you are here, then pieces of paper here. So there is no attraction. TV screen at home, you are in school or college, then no attractive force. So to get that attractive force, they should maintain at some particular distance. How the force is going to act between these two charges is given by Coulomb's. Therefore, we will say Coulomb's inverse pair law. So this electric force, everyone came to know, product of magnitude of their charges and inversely proportional to square of the distance between them. So see here, we are taking product of magnitude of two charges. If it is positive, negative, you no need to worry. Always we have to take magnitude. So this F is directly proportional to Q1, Q2 by R square. We will write one constant. That constant only we will say F is equal to 1 by 4 pi epsilon naught Q1, Q2 by R square. So what is this epsilon naught means? Epsilon naught is permittivity of free space. So we will discuss about later this one. What is the permittivity? It is going to permit. What it is going to permit means how electric field lines will be going. So but here our concentration is how much force is acting now. Therefore later we will discuss about this. This F is equal to 1 by 4 pi epsilon naught. We won't write always. Simply we will write K. Here K is 1 by 4 pi epsilon constant Q1 Q2 by R square. So this K value 1 by 4 pi epsilon naught value. So what is 1 by 4 pi epsilon naught value means 9 into 10 power 9. So already we were discussing, who are following our channel, they came to know. So we are discussing about dimensional formulas. So what is the dimension formula for permittivity of free space, they will ask. At the time you want a unit for this. You can bring this 4 pi epsilon naught left side. So 4 pi epsilon naught is Q1 Q2 by R square into F. So epsilon naught dimension formula you want. 4 pi is constant, you can leave. What is charge dimension formula? We said AT, another charge AT, distance square, L square, force dimension formula MLT power minus 2. If you send it to numerator, you are going to get the dimension formula for this. If you want to get the unit for this, unit also you can get Coulomb square per Newton meter square. Coulomb square per Newton meter square you are going to get. This is the dimension formula. Now how we are going to use this one mainly for problems, and what is the nature of the electrostatic force. If these two charges, let us assume plus Q1 plus Q2, these two charges are positive, then force is going to be repulsive force. Always same charges repel each other. If one is positive, one is negative, then force is going to be attractive. If separation is R, what is the force between two positive charges means K Q1 Q2 by R square. Between positive and negative charges also we will write K Q1 Q2 by R square. Then what is the difference between these two means this is also magnitude, this is also magnitude, magnitude will be same. Then what is different means direction you can say. Here direction is acting away, here direction is towards. So these are attracting, these are going to repel each other. So but magnitude is going to be same. That one you should remember very carefully. Therefore here we are saying force of attraction or repulsion is always directly proportional to product of magnitude of their charges. This negative charge will indicate only either attraction or repulsion. Magnitude always remains same. So between positive charge, force is going to be repulsive. It acts along line joining the centers of those two charges. Therefore, this force we will say central force. So Coulomb force is a central force. If one positive charge, one negative charge they have taken, then these are going to attract like this. Again, this is also acting along their centers. So one is negative, another one also negative. This is also which force? Repulsive force. Because same charges always repel, opposite charges always attract each other. That one only they will say like charges, unlike charges. Like charges always repel, unlike charges always attract each other. Now see the problems how they are going to ask. Once we got the equation, we should come to know how the problems they are going to ask. This is the equation for each and every one. K Q1 Q2 by R square. First you can see how many number of variables are there, unknowns. F is unknown, Q1 Q2 unknown, R unknown. So 1, 2, 3, 4. So 3 unknowns. Otherwise, if both are charges they gave, then 3 unknowns. Force, charge, distance. Then 2 unknowns they will give. 2 known things they will give. 1 unknown thing they are going to give. So problem we will learn how to create and how to write. So first a very simple problem. So what is the force between two charges? Plus 3 microcoulomb minus 3 microcoulomb at some separation 3 meters. Two charges plus 3 minus 3 separated by 3 meters distance. Now what is the Coulomb force or attractive force or repulsive force between them? So here nature, one is positive, one is negative. Therefore, so plus 3 will be attracted by minus 3 like this, minus 3 will be attracted by plus 3 like this. Therefore, this is the nature of forces will be here attractive. Now, what is its magnitude according to this formula? So, F is equal to, what is K value we said? 9 into 10 power 9. Now, what is Q1? 3 into 10 power minus 6. In previous video we said micro means. Here we should take plus or minus means here we have to take this is magnitude. Therefore, 3 into 10 power minus 6. If you write minus also here no problem. Here negative sign indicates force is attractive. Divided by R square. R square is nothing but 3 square. Now see 3 square is nothing but 9. 9 will be cancelled. 3 into 3, 9. So 10 power 9 minus 6 minus 6. So 9 into 10 power, how much you are going to get? So 9 minus 12 or 9 minus 6 is 3. So you are going to get minus 3 newtons. So 9 millinewtons. This is the how much force means 9 millinewtons. This force is going to be attractive. In options they may give like this attractive force how much means 9 millinewtons. Now same question if they give 3 centimeters, isn't it? 3 centimeters they give. Then how the question is going to be changed you can see. So F is equal to same equation 9 into 10 power 9. What is Q1? Same 3 into 10 power minus 6. 3 into 10 power minus 6. So you no need to worry about negative sign while substituting. Now 3 centimeters. So 3 centimeters you have to convert into meters. So 3 into 10 power minus 2 meters. How that one came means very simple. 1 meter is equal to 100 centimeters. So 1 centimeter is equal to 1 by 100 meters. So 1 by 100 meters they can write it as 10 power minus 2. Otherwise, if you want to write another step, 1 by 10 square, 10 power minus 2 meters. Here our concentration is not this one. So, conversion of unit into meter, that is going to be important. Now, 3 into 10 power minus 2 whole square. Now, you can expand this. 9 into 10 power 9. 3 3s are 9. Minus 6 minus 6. Otherwise, you can write like that only. No problem. 3 square. 9. 10 power minus 2 whole square. So, how much you are going to get? You can see 9 9 will be cancelled. 9 minus 6 minus 6. 9 minus 6 minus 6 will be 10 power minus 3. This 9 I am writing here. 10 power minus 3 divided by. Here you can cross check. 10 power minus 2 into 2. Minus 4. If it is going to numerator, 9 into 10 power minus 3, 10 power 4. 9 into 10 power 4 minus 3. That is going to be 9 into 10, 90 newtons. See the answer how it is going to be changed whenever simply by changing units. Like this you can do with, you can practice with 3 millicoulomb minus 3 millicoulomb, plus 10 microcoulomb minus 10 microcoulomb, plus 10 coulomb plus minus 10 coulomb, otherwise plus 10 minus 10 till you got irritation. If you practice like this, definitely you people will remember this. First we should come to know how to apply the formula. We'll be getting information according to the given data. In these two charges distance they gave, two charges distance they gave. So they're asking force. Therefore you will get automatically idea which formula you're going to apply. Next, two charges they will give, Q1 and Q2. Distance between them is smaller. Then what is the force between these two charges means? F is equal to KQ1 Q2 by R square. Now, distance between these two charges doubled, increases 2 times, increases by 2 times. So, our first video about directly proportional and inversely proportional we said. So, if you remember that video or if you apply problems on that, directly you can get the answer. Otherwise, we have to solve like this. So, Q2, distance between these two is R, force between them is F. Now, distance between the two charges, both Q1 and Q2 is double. New distance is going to be 2R. They didn't change any charges. Same charges, the distance is going to be double. Then what is the new force between them? F dash they will ask. This new distance is R dash. So here charges constant. Therefore, our formula K Q1 Q2 by R square. K is constant, Q1 Q2 constants. Here force and distance relation. F is inversely proportional to R square. Then F by F dash equal to R dash square by R square. Otherwise, you can write F1 by F2 is R2 by R1 whole square, like that or like this. That is your wish. So this much also not required. If you remember that inversely proportional A, directly proportional to B, inversely proportional to B, B square. If you remember that, directly you can get the answer. Now what is R dash here? 2R. Substitute here. So 2R whole square by R square. So 2R whole square by R square means this is going to be 4. 4R square by R square. Then F by F dash is 4. Then F dash is going to be how much? F by 4. If distance increases, R increases, force is going to decrease. Therefore, a square is there. Here 2 powers 2 will be coming, 2 square will be coming, force decreases, therefore F by 4. If distance is double, force is going to become F by 4 means if distance is half. Q1, Q2. Let us assume R dash is R by 2. Then what happens to force? This is only logic you have to apply very fastly. So here distance is double means R increases means force became 1 by 4. Now distance is half means R decreases. At the time force increases. How much it will increase means here F by 4 you will get 4F. If you want means you can cross check once. F by F dash equal to R dash square by R square. Now what is R dash? We have to write R by 2. R by 2 whole square by R square. So R square by 4R square. So this is f by f dash. Then what is f dash? 4f. So same question. Distance between two charges. Distance between two charges increases by 2 times. Increases by 2 times. Then what you have to take means r dash is going to be r plus 2r. Then it is going to be 3r. If we are taking 2r, our answer will be f by 4. If we are taking 3r, what is our answer? F by 9. Like this we have to do the problems. So this is like directly proportional and inversely proportional. Understood? This is about distance increases, distance half. Like this, you have to solve the problems. So next model we will see, if two charges Q1 and Q2 separated by distance r, then force between them is k Q1 Q2 by r square. Now see, charges, one of the charge is doubled, Q1 dash is 2Q1, one of the charge is tripled, 3Q2. So without changing the separation. So one of the charge is doubled, another charge is tripled. Then what is the new force between them? They will ask. At that time, according to our formula, force is directly proportional to Q1 and Q2. Now R and K is same. Therefore, F is directly proportional to Q1 and Q2. F dash is directly proportional to Q1 dash, Q2 dash we have to take. So after taking like this, F dash by F equal to Q1 dash, Q2 dash by Q1, Q2. Now what is Q1 dash value? Q1 dash is one of the charge increases 2 times, 2Q1. Another charge tripled, 3Q2. So Q1, Q2. At the time, these two will be cancelled. So F dash by F is equal to 6. F dash equal to force increases 6 times. Directly also we can do. This is Q1, Q2. If it is doubled, triple 2 into 3. Directly also we can do. Again, this is also concept of directly proportional and inversely proportional. So our first video we have done on this directly proportional and inversely proportional with A and B. Isn't it? If you want to do another problem on this, one of the charges Q1 dash, one of the charges tripled Q1 dash, another charge is Q2 dash is going to be quadrupled for Q2 without changing the separation. Now you will get directly answer. F dash is going to be 4 into 3, 12F. So this time is going to be solved whenever you are solving the problem. This entire time or steps are going to be reduced just by practicing. So without practicing, we can't get the problems very fastly. So you have to practice like this by changing the numbers. Then we are going to get answers fastly. Now one of the charge is half. So another charge is double without changing the distance. Now what is the new force? What is the new force means what we have to do? F dash is 1 by 2 into 2. That is going to be force remains same. So like this they are going to ask the problems. So you have to solve like this. So this one today we discussed doubled, tripled, half, 1 by 4 or 4 times we can practice like this. In next session we will do if percentage of the charge is increased. Q1 increases 10%, Q2 increases 10%, Q1 increases 10%, Q2 decreases 10%. So percentage problems we will solve. So before going to solve that, you have to see once that directly proportional, inversely proportional video, then fastly you are going to get the answer. Otherwise, we will do in next video. You people can see and solve the problems easily. Thank you.